Hi everybody, my name's Ben Weeks and I'm the CTO at Requestec. Requestec's actually been around since 2002 and we got started out in messaging, which we were quite successful at, and it was quite straightforward. And then in 2007 we decided to get into video, and I must admit that a few times since then I've regretted that decision because video is quite a difficult thing to do. But fortunately in the last couple of years we've overcome quite a few of the challenges, and we have some excellent deployments now in the enterprise, and I'm going to show you some of those today, as well as the challenges that we've had and how we've overcome those. So yeah, we have live deployments in healthcare, largely the National Health Service in the UK. We have 12 trusts live, and here in the US with Medtronic, where they train patients to use things like diabetic pumps and other training and medical services online. We also do video banking, both in the online banking, out of online banking as a sort of customer representative, customer services, but also regular advisory sessions where you meet your bank manager every quarter to talk about your investments. And education is another big use case where people meet in groups to be educated in online language courses and other types of things. So here's an example from a National Health Service medical deployment where this is our online meeting room, and not the entire screen is given over to video. A large part of it is a collaboration area in the middle where there's a whiteboard that we can share pictures and documents which both the patient and the doctor can draw on in real time. It's also possible to fill out forms in this area and have the customer or the patient just press accept to submit the form. So here's an example from an education space, and in this situation we have 4 people in a video multi-layout. It's possible to rearrange the video area based on who's talking or who's the active speaker or who's the most important person in the session. And there's a number of different MCU layouts to cater for different environments. So here's another one. And on the left you can see there's a list of attendees, and it's possible for the person who's presenting the meeting to mute people or to promote them or to eject them from the call. In the middle here, there's a PowerPoint presentation being shared, and the PowerPoint retains all of its transitions. It's pure HTML5, and that allows people to talk about different subject matter while they're in their meetings. Okay, so the main sort of summary of our meeting room features is we have a voice-activated positioning of people. There's multiple conferencing layouts that I showed you. It's possible to screen share using WebRTC screen share, which works really well now out to mobile devices as well as desktop. Instant messaging, file sharing, PowerPoint presenting, and even co-browsing. So this is a really good use case from a European banking deployment that we have live now, where the advisor is visible in the top right-hand corner, but is actually sharing their screen at the same time. So rather than having to upload any documents before the meeting begins, they can just use the PowerPoint that's present on their PC desktop and show the customer their portfolio of investments. And interestingly, and this is very good news for us all really, is that there's now evidence to suggest that these banks are doing more efficient business, both in terms of cost of running the meeting, but the customer is more likely to convert to buying a new product they find if they're doing it from the comfort and convenience of their web browser at home. So video really is moving from a nice to have customer services thing of looking better than your competition to actually driving more revenue through a better way of doing business. And with this type of evidence coming in, the orders for more ports for providing this type of thing is going to ramp up quite significantly. And also on mobile, it's possible to WebRTC screen share out to the device, and it works just as well. I've actually got a live, for those of you, oh no, sorry, it doesn't show, but the screen here is that I'm actually see, which is different to what's up there because this is the presenter view that I'm seeing, is being streamed live to my iPad here, and the quality is actually very good and clear, and perhaps Scott here could show that around. The view on my laptop here, which I've not seen before, is different to what you see up there. I've got like a presenter view of the PowerPoint sharing. Okay, so coming on to more of a customer call center environment, where within a web page you can click to talk to customer services representative, and from there you can escalate that into a video call and even escalate it further into instant messaging and whiteboard. So it can grow out of a web page into a full-blown meeting environment. And that will be routed perhaps through a SIP server in a call center, and we have live deployments with Genesis, who are a big call center firm at various different enterprises. So this shows a Google Calendar meeting appointment, and most of the interactions that customers have will always begin with a personalized fast track link, which might be delivered to them in an email such as this, but also with inside online banking. If your meeting is about to start, you would log in to regular online banking, and there'd be a link there which is personalized to you and takes you into the meeting space. But we also provide second level of authentication to make sure that the person clicking the link really is the person who is intended to. And there's a number of ways of doing this, including single sign-on or SAML, which is security authentication markup language, which is quite common in banks, to make sure that the person can then log into the bank system again, or perhaps it's the bank staff who are logging into the bank system using Kerberos or something. So we find that a lot of the work that we have to do to put this into the enterprise is around authenticating the people joining into the meeting. We also use SMS text messages to let people know that their appointments have been made, because when you send out an email, it's not always guaranteed that the person has read the email. So if a hospital appointment's been set up, you need a little bit more than just sending out an email to be sure that the person has received it. So they often confirm the appointment by way of SMS. Right, so I think if you were to compare us to something like TalkBox, even though we do run a cloud service for some of our customers, most of what we do tends to be putting our servers into the data centers of enterprises, because they don't want any of the traffic going outside of their network. It's very sensitive data quite often, and they like to have full control over it. So we tend to be specialized in the authentication, as I mentioned, but installing it on site for the bank or the hospital to run it themselves. So some of the big challenges that we come up against and have overcome, probably the biggest one is that most people, you know, my mother, my grandmother, etc., they're not used to this type of technology. And they might only have 3 or 4 meetings a year with the hospital or with the bank, and they don't know what WebRTC is. They never need to know what WebRTC is. But they do find it quite difficult sometimes to get into meetings. And we find that if there's one bit of negative feedback, the bank or the hospital will completely review their decision to go down this road, because they're quite happy, well, not necessarily quite happy, but they're doing a good job at the moment. And any negative press or people complaining is a big no-no. So we've had to put a lot of work into making this as simple as possible for average people to enter into the meeting. And I'll show you how we do that in a minute. Another challenge that we have is a lot of enterprises don't want to install Chrome because it's an open source web browser, and it presents security problems and vulnerabilities, because it's open source, but also maybe it's sharing information with Google, which they're not happy about, usage of their employees and this type of thing. We come up against strict corporate firewalls, where the idea of opening up multiple UDP ports is absolutely not allowed. One UDP port at the most is all you'll get away with. And we have varying recording requirements, some which by law mean that if the recording is not taking place, that meeting has to stop. So we actually have to validate the recording in real time to make sure it can be played back. And as we write the recording, quite often we do it in an encrypted way, such that our software wouldn't be able to read it again without the private key of the bank or the hospital that we encrypt the recording with as we write it to disk. So if our engineers had to go and look at something, there's no way that even if that recording got out of there, or if it was in our cloud, for example, we couldn't watch that recording back. And that's really quite a useful thing for ticking a few data and information governance issues, certainly in the healthcare market. And yeah, multi-party video conferencing, you'll hear a lot of different strategies that people use or can use to provide good quality multi-party conferencing. And actually we've got use cases which require all three of the main types, which are peer-to-peer conferencing, composited conferencing, and also selective forwarding of streams. And I'm going to show you some use cases where each of those different ways of doing it is actually the best for that particular case. So the first challenge that we overcome is with regular users accessing it. And I can actually give you a live demonstration of this, I think. Now you might find this a bit of a horrible thing in some ways, that people have to go through this process in order to enter a meeting. But bearing in mind that a lot of these meetings, they only do them 4 times a year, it's much better to make sure that everything's working when they get in the meeting than it isn't. So here you just saw a speed check taking place. Now that was a real voice and video packet being sent and received to the turn server that they might be using. It's not using some other internet speed tester. That was a real voice and video call taking place between my computer and a turn server, so that we know what the upload speed and download speed is like and whether or not they're going to be able to have a good video call. If they can't, we might advise them to to make sure that nobody else is using the internet at home for YouTube, etc., because a lot of people don't realize that if other people are using it, it's going to affect their video call. And also, this is a big thing, to get close to the router. If you take your iPad sometimes 2 rooms away from your Wi-Fi router, the packet loss is so significant that the call will be terrible. So we can try and educate people to get closer to the router, to tell other people not to use to use the internet at this time, and they can rerun the test if they want, such that they know now that they have acceptable bandwidth to proceed to the next stage. And the next stage is to test the speakers on their computer. So their headset might not be plugged in, or they might not have any speakers. We've had doctors before go to an appointment and he didn't have any speakers attached to his computer. So here, this isn't plugged in, but this is now playing out some music, and I confirm that I can hear it. The music that we use is using the instrument, the cello, and the reason for that is because A, we don't have to translate it into lots of different languages, and B, the cello is the closest of all known instruments to the human voice. So it gives you a good feeling of how another person is going to sound on that video call. Okay, so I've confirmed that's fine. And now you can see that my microphone is being picked up, and as I talk in real time, that is moving. So we know that the speakers are working, we know that the microphone's working, and we know that the internet is good enough to proceed into what is a very important meeting, be it health or banking related. I can actually change my microphone if I wasn't happy with it and choose a different one on the machine. So the next thing and last thing that we have to make sure is working is the camera. And again, I can change my camera. I can choose a different one from the drop down. None of those, well, as you notice up here, there is a Google Chrome way of changing it, but that is completely not obvious or invisible to most people. So we've brought that down into the page, made it nice and friendly, and you can't proceed unless you're ticking all the boxes. And that brings you to the end of the tech check, which we have successfully passed. And we now put this as standard into all of our meeting room access, so that we don't get complaints that this didn't work or that didn't work, because quite often it's too late to analyze it. You'll hear that some patient got into a meeting, no one knows why it went wrong, and they certainly won't be using that service again and telling their friends that it was terrible. So now we know that if you get into the meeting, it's going to be good. So I can go back to my PowerPoint now, hopefully, and just zip through these slides, which you've already seen. So yeah, that's how we make WebRTC and video calling accessible to the masses. The next big problem that we have is that WebRTC is not available in all web browsers. And while I applaud people putting WebRTC into plugins, it's definitely not an acceptable solution. For a start, you can't have one click through to your meeting. People might find that their plugin doesn't install properly, there's issues with it, and then the company, the enterprise, is then responsible for what might happen to that computer. Even if the plugin is completely not responsible, somebody installing something, restarting their browser, then noticing that their computer's not running properly or slowly next week, might think it's to do with the plugin. And again, companies that don't like open source browsers wouldn't be happy about having a third-party ActiveX control running on their desktops, which has got the open source WebRTC bundled up inside it. So the real solution that we have here is to use Flash. And before you gasp, there's two different types of Flash. There's RTMP, which is a TCP-based protocol, which does have delays. But there's also RTMFP, which is a UDP-based protocol, and it uses H.264. So it actually produces the same quality of video as WebRTC. And I think, unless anyone can tell me that I'm wrong, that we're the only company in the world that can do RTMFP to WebRTC video calling. And you can see it over there at the table. You can see Flash on one side, WebRTC on the other side, and you wouldn't know the difference because the only bit which is Flash is the video window. Everything else is exactly the same, HTML5. And this is why, time and again, we beat quite a few of the big names in RFPs and get chosen for projects because we work in all web browsers today. So, recording and archiving. We offer a number of different recording options. You can record just the voice and the video, but we also have the ability to record the whole meeting room space as I showed it to you in the server as well. So it's not like you're uploading the video from the browser window, but within the server, we know what that whole browser window looks like, and we're able to record it in real time to disk in an encrypted way, as I mentioned before. And if it's necessary for regulatory reasons, we can stop that meeting going on if, say, there's no recording space on the disk to record anymore, or for some reason the file has become corrupted, which never really happens, but it does prove that if a meeting takes place, it will be recorded. One last little point here. It's also possible to write the MP4 in real time, but some banks who have excess CPU power at night would rather composite those streams when there's nothing else going on in the bank. So we have a way of dumping all the raw data to disk and then compositing overnight when there's CPU power available. This is an example of a typical architecture diagram for a deployment at a bank. We have a sort of application server, which is the blue bit, where there's an active and a passive, so it has high availability, and that is responsible for directing the user and the meeting to an available media and notification server. And they're shown in green, and they scale horizontally such that they can be taken into and they can be added to the farm and taken out of the farm for maintenance and to extend the scalability of the deployment as it becomes busier. So it's a highly scalable design and allows for maintenance. We've got a turn server over here on the left, which for a lot of organizations who won't open up their firewall is the only way to get the media in and out of the enterprise securely. It doesn't add any more latency than a firewall router, and it does provide security at the turn level protocol. So all of the calls here will actually go through a turn server, and that's totally acceptable, and that's the only way to do this in the enterprise environment. Right, so now I'm going to talk about and not too much time left, I'm going to talk about the three main different conferencing modes and when each of them might be used. This is showing, so I want to just start with the peer-to-peer one. In a peer-to-peer conference, everybody is sending video to everybody else. The obvious downside of that is that every time somebody joins, you're reducing your upload ability. But when you've only got 2 or 3 people, the latency is fantastic, and for some services where there's one example that I've got where there's 40,000 people connected at any one time, the mind boggles when you think how many servers you would have to have if all of that was going through an SVC router. We're talking tens of racks. So where you can do peer-to-peer calling and conferencing, it's a really good thing to do. And we even have the ability to put one of our recording servers as a node here, such that it's still possible to record within the server environment, but have the peer-to-peer mesh going on outside. But as that starts to break down, perhaps because somebody's bandwidth's not good enough, it's possible to, or if it's a requirement, to move over to the SFU model, where everybody is sending their media into a server, and that's being routed out to all the different people in the conference. And that provides the same good quality, but it does provide a slightly more burden on the infrastructure of the enterprise. And then the composite stream. This is where you take the streams and you re-encode it into a single composite stream and send it out to the device. We've got quite a good optimization on this in that we send the same composited stream to all the people that need it. Now, there are some mobile devices which benefit more from having a single stream, and the Flash client works better with not having multiple streams. So we send them all the same composited view, but that could be quite annoying if you see yourself within the composited view, but slightly delayed. And what we do there is we put your local video over the exact coordinates of yourself in the composited view, so it looks just as it would do in a normal conference. And you can see that at work over there as well. And it means that we can have a single encoding session with as many people in the room. Well, we only really show 9 people at any one time, but with 9 people in a room, you only have one composited encoding session. And we're also able to use that same encoding session as a recording as well, so it doubles up as both. And if you've got people, maybe 100 or up to 128 viewing this particular room, they can all be sent the same encoded session. So hopefully there I gave you some use cases why actually each of these different conferencing models does have a validity today. I can't wait to see SVC for real, to be usable in the web browser. But for now, mixing between these 3 different modes based on the use case that you have, and sometimes switching from one to another during the call. There might be 2 seconds where you see a little spinner, but it'll never go back again. That's kind of the best way to achieve that. And this is just the last slide now, which kind of shows you what our SDKs look like when we develop the rooms. We tend to share the code and the SDKs with the enterprises that we work with. They like to be able to take it from us and extend it, and we generally share most of the source code actually for the platform, except the conferencing engine, so that they can own that going forwards and not be too dependent on us. But this shows the main pods from a meeting room, so the video pod, the IM, the whiteboard, and they can all be resized, made full screen, dragged around, and then saved as a meeting room layout. And there's just one little line of code split onto a few lines there, which shows how you might configure and embed a video pod, and then all the styling is just done through CSS. And this works on both web and mobile. So it really is a very rapid application development environment for rolling out services which do work in the field today. And that's it. Thank you all very much for listening, and I hope to be able to give you a demo over there.